Hey, what's going on? J-List Exec here. This week we're looking at ratcheting. This is a really simple and, again, it's a powerful technique that goes right back to the early days of modular. Commonly, this technique's associated with Tangerine Dream, and it goes back to, if you think about the fundamentals of working in this way, in this kind of modular way, thus far we've only dealt with fixed clock and we haven't dealt with anything to do with dynamics. So being able to move in and out of different note resolutions, this is in many ways the easiest way to do it. And so the other good thing about this particular method is that we can just use the tools that we already have seen. We're not going to really introduce anything new into this particular tune. So let's make a simple definition of what ratcheting is. If we think about the simplest definition of ratcheting, it is being able to, on a particular step of a sequence, play that particular step an amount of times. So we can repeat that step. So it's, in many ways, it's just kind of like a retrigger. And the way that we're going to be doing it here is similar to last week. We're just going to have global controls. So if we look here in the demonstration patcher, we're using probability to enable ratcheting on the particular step. So if we turn probability to 100%, every single step will be affected by the ratcheting. And we've got a new parameter here for the amount of steps that we want to enable for each ratcheted step. So let's have a listen. This is just our simple piano sequence from last week. So with every step enabled for ratcheting, it doesn't make a great deal of sense. So if we use probability to reduce this to only occasionally ratchet the step, so you can see where it gets that name ratcheting from. And this is also really, really effective on drums. So really, really simple technique, and let's show you how to do it. So in the interest of simplicity, I'm just using the same patch where we ended the last tutorial. So this is exactly where we ended up. And I'm going to make our job a little bit simpler, and I'm going to remove some of this stuff just to cut down on clutter. So you can put any samples you choose into this playlist tilde, and we're just going to work with a single playlist tilde here. Cool. So pause the video if you need to go and get the patcher from last week and paste it in or build on that one. In our Gen patcher, you can see here that we've got the exact same system that we left off with. So let's work from the UI backwards. Let's make the new controls that we need, and then we'll start building on our Gen patcher. So we're going to need a new live.dial to control our steps for our ratcheting. And so all you need to do is to change the range to whatever you like, but I'll make mine 1 to 16. So we'll need to open up this sub-patcher here, and we'll need to create another prepend. And this is how we're going to communicate with the param that we are about to build. Cool. So we just need to run our outlet from our dial into that inlet. And we'll change the short name. Cool. So we've got our controls for the amount of steps that we'd like when ratcheting is enabled. So now that we have that UI control, let's just copy the string that we've used here, the symbol, and we'll make a new param inside our gen patcher, paste in the name, and then for a default, we'll use 1, and for a minimum, we'll use 1, and the maximum will be 16, or whatever you've chosen to use for the attribute of the parameter here in the live.dial. So how do we begin to enable this? The good news is that it's really, really simple. It's just based on stuff we've already done. We really just need to be able to multiply the phaser that's coming out here by the amount of steps. So first of all, let's create a new live.scope. And this will be our debug view while we're developing our ratcheting system. So we'll make ourselves a new outlet. Cool, so down here we've got a live.scope that's going to be our debug view, and we'll need to do what we do whenever we're working in the trigger realm, which is generally between 0 and 1. So we just give ourselves a little bit of room either side, just like we've been doing every other tube. So this is our debug view down here. So in order to create our ratcheting effect, we'll need to have a phaser ramp for each of these individual steps, and we already have that. So if I just connect up our modulo 1 here to our new outlet, this is a phaser ramp for each step. So if we change the amount of steps up here, you can see that we've got one ramp that goes from 0 from the beginning of the step to 1 to the end of the step. And so all we need to do here is we need to simply multiply this by our new param, which is the ratchet steps, and then modulo it one more time. So now if I change the ratchet steps, we'll have 3 for each step. This is just multiplying the phaser. So in our implementation using playlist tilde, we actually are only dealing with integers. We're dealing with integers that control the particular index of the sample within playlist tilde. So in order to work with that, we're going to need to move away from the phaser amps that we're using. And we have a look at our gen patcher here. The step index is coming out of the ceiling operator. So what we'd like to do is, if the probability gate is high, we'd like to re-trigger that particular index. So the first thing that we'll need to do is to turn our phaser ramp into a gate. And a very simple way to do that is to first consider when in the phaser ramp we'd like to hold the gate high. So in some cases, you might want to hold the gate high towards the end of the phase of the phaser ramp. And in others, like in our particular case, we really want the start of the transient to occur. So we're going to chop the end off the gate. And we'll just use less than 0.99 to do that. So you can see here that we've turned our phaser ramps into gates. And because this gate is just dealing with zeros and ones, we can use this to multiply the existing step by that number. So out of this ceiling operator, which is our step index, we just simply multiply our new gate by that number. And if you like, you can use a send and receive pair. So to just make it a bit more legible, we're using a send and receive pair here. And just make sure that you color code these, just improves legibility. So the first thing that you'll notice is that this is going out of the range of our live.scope, and that is because this particular index we're dealing with 1 to 8. So our range on our live.scope isn't going to allow us to see it. So if we'd like to continue working with this debug view, we might need to create a new outlet, one for debug. And then in order to deal with stuff for our live.scope, we need to divide by the number of steps in our sequence, the maximum steps. So we can use our param one more time. And then we simply need to just use the outlet that we've just made and switch that over. So we're just normalizing that here. So we're nearly done. All we need to do is, at the moment, when the probability gate is low, we get no throughput. And that's not what we actually want at the moment. We want to pass through the current step index so that when the gate is low, it's just the normal step. And at the moment, we're not doing that. So when we need to toggle between two different states, we just need to use our ternary operator like we've used before. And I'll give myself a little bit more room here. So we need to be able to toggle between two different states, and the condition that's going to control those different states is our probability gate here. And once again, I might use a send and receive pair just to make this a bit clearer. So if you remember from last week's tute, this outlet that comes out of this second outlet from our probability abstraction, this is the red gate that you're seeing here. This is where it originates. So I'm just sending that over to our ternary. So when our gate is high, we want to pass through this new piece of logic that we've created here. So when the gate is held high, this new piece of logic that we've created will be passed through. And if the gate is low, we would just like to pass in the step index. So you can see here that we're just kind of chopping up that step using our gate. So this is mostly everything that we need to do. The other thing that we need to consider is the envelope shape is going to change based on this. And over here, we're using the envelope only for the non-ratcheted steps. So we're going to need to modify this a bit. So before we do that, let's create a new live.scope in order to debug what we're creating. So out of the fourth outlet is the probability envelope. So we need to modify our implementation here. We need that every step when it occurs, we want our envelope to happen. And then we also want to be able to change the retriggering of that envelope for these steps here. So we're going to need to modify our envelope a bit. You can see here that the only steps that this envelope is being applied to is the steps where the probability gate is held high. And that's no longer what we want to do. So the piece of logic that's creating that effect is the multiplication operator. We're just multiplying that phase around by whether the gate is held high or not. So if we delete that and then we run this phasor ramp directly into our triangle wavetable, we get our triangle envelope for every step. What we'd like to do is when the gate is high, we would like to multiply that by our new rate over here. So we can use a ternary to do that. And the condition for the ternary will be the probability gate again. And in fact, I'm going to use this from over here. It's just the exact same signal. And then if the gate is high, we would like to use our new rate from over here. So we'll pass that into the true inlet. And then if it's false, we just like to use this one. So you should be able to see here that when our gate is open, we are multiplying the rate of this phaser in accordance with our new rate. And when it is low, we're just using the original rate here. So this is our this is our envelope. So that means that whenever we've got a ratcheted step, we can control the tightness of that envelope. That'll help a lot for clarity. So we do have our control here for our envelope shape. You can see that we can alter the angle of our AD envelope. And this is limited, but it will work for our purposes. So let's start using that. So I'm going to make a new playlist tilde, and I'm going to use the Amen break that I used in the demo patcher. And this is, just chop this again, chop this up in Audacity, and I just chop one bar. So before we can have a listen to this, we'll need to firstly control this probability step IDX. I'm just going to rename this for clarity. So our ratchet step index is actually coming out of outlet 5. And our ratchet envelope is still coming out of outlet 4. So we just only need to change the outlet for our ratchet step index. And then if we turn sound up, you can see here that we've got the envelope overlaid over the audio coming through. So we don't actually need our debug view down here. You can see the white line for our envelope is the same here. So we've got control over our envelope just like we did before. And so that's basically it. That's basically our ratcheting. Obviously, we could take this a lot further, being deterministic and not being probabilistic. And we'll do that in the future. But firstly, I just want to be able to show you a quick method to be able to make a bit more out of our AD envelope here. What would be nice is that you can see here we're chopping on that angle, and we'd like to be able to kind of curve that out, and that'll give each transient a bit more body. So let's just quickly make that in our envelope here. So what we'd like to be able to do is to control the decay phase of our AD envelope. And a simple way to do that is we can use the slide operator to logarithmically filter that down. And we can insert this into the output of our triangle operator. I'm just going to use a constant here for the attack phase. We want to keep that nice and sharp, but we'd like to just perform this on the decay. So why don't we use another param here? So you can adjust these numbers to taste. I'm just using a default of 100 and a minimum of 1 and then a maximum of 2000. And just remember that these are in samples. So we just really want to pipe this directly in. So out here in the parent patcher, we'll just need to give ourselves a little bit more room and create a new live.dial. Just quickly change the short name to decay slope. And then we'll make the range between 1 and 2000. So we'll need to create a new prepend here. So we've got our new decay slope param here, and let's have a listen to how it affects the sound. So you can see we can use that this slope of the decay to give more body to each hit. We're kind of working around the limitations of our AD envelope. So it gives us a little bit more expression. And speaking of expression, we haven't really been covering dynamics at all in any of these tutorials. So in some upcoming tutes, we're going to devote some time to things like ADSR envelopes, how to create them, and how to create more amplitudinal shapes that we can control and give us more expression. And in order to do some of that stuff, we're going to need to use CodeBox. So this series is going to take a break for a couple of weeks, and I'm going to build up the next round of tutorials in this series, and we're going to move into this next stage. So this first bracket of tutorials that we've covered thus far, that's going to kind of constitute the beginner stuff, and then we're going to incrementally work more in towards the intermediate stuff. So I know at least some of you have been really keen to get into that stuff. So I really look forward to getting to that next step. So yeah, I hope you've enjoyed this particular tute. I'd encourage you to think about how you might go beyond this global params and think about how you might do it discreetly for each step, and some of the UI control mechanisms that you might choose to do that with. When we return to this series, I'll start expanding that out, so we'll start approaching things that way too. So yeah, thanks again, everyone. I look forward to seeing you in a couple of weeks. Cheers.